Hello, everyone. Welcome once again to your study part. Today, we continue in our revision series talking about our UTME examination. Welcome to class. I remain your teacher, Mr. Femi. So, we'll get right into the business of today. As our UTME examination is approaching, we want to take a statistical overview of how far we have actually been able to get ourselves in tune with the topics we have for the examination. So far, we've treated like six topics in all based on the revision process. But for a fact, when you pick a past question to solve a particular year, take an assessment to know exactly what level your performance rate is at the moment. So how can you do that? Quickly, take your past question out, set yourself a 2-hour time frame, then pick 4 years of your choice from your past question. You are to answer 4 years PQ within 2 hours. You doing this now would warrant and condition you to understanding that you are using 200 questions in 2 hours. And with this, you can take an average from whatever you score over 200. You take an average and you know what your score would be in terms of 400 marks. Or better still, over 100, whatever you score from all your marks, convert it to 100%. So let's assume you score X over 200 times 100%. You get to know where your standing is, talking about your physics examination preparation. So today we are looking at machines. Not because we are not familiar with machines already. Certainly some of us know machines as the case is, but we want to lay emphasis on the areas your UTME examination is going to be centered around. We want to look at aspects of your machines, which you might have forgotten, but emphasis are placed on. So what are those areas? That's what we are going to consider today. So first up, the outline of what we'll be looking at. Not really because it is important. Certainly, JAMB as a body would not certainly be asking you the definition, but at least for a start, you should have an idea of what a machine is. Then, you should be able to familiarize yourself with formulas relating to mechanical advantage, velocity ratio, and efficiency. You should be able to associate formulas relating velocity ratio in terms of the mechanical advantage as well as efficiency. Then when you are able to do this, the third aspect under your machines, which your examination is centered on, would be being able to identify the velocity ratio. I was supposed to write that in full. Velocity ratio, VR, of various machines. That's all. Everything you want to know about machine, talking about your UTME examination, talking about the past question you have with you at the moment, is centerpiece on these 3 aspects only. Once you are good to go with these 3 aspects, trust me, any question on the machine is a walkover for you. So let's start. The definition, like I said, it is not that important. You won't see it inside your past question. Go check it out. But at least for a start, you should know what exactly a machine is. So we say, what are machines? A machine is simply any device in which a force applied would always be used to overcome what? A given load. A force applied is always used to overcome what? A given load. Meaning that you put in effort with respect to the machine and it will result in overcoming what? A given load. In the general way which you have known before now, we say that a machine is any device that makes work done faster, easier, and saving what? Time and energy. So, all those ones are basic. We really don't need them. But let's have it. So, the second one, we said it is also any device or tool by means of which effort or force applied is used to overcome a given load. And why is this true? You take your hand fan. Your hand fan, you actually apply some level of effort into it to overcome what? A given problem. What is the load? The heat energy around you, which you're experiencing. So, the movement of the hand fan produces breeze, cool breeze, which tends to what? Overcome the heat that is what's surrounding your body at that instance. Now, having taken out the definition of machines to the business of the day, the main domain, we talk about what? The formulas relating what? Mechanical advantage to velocity ratio as well as efficiency. What are they? Formulas on the machine. Formulas on the machine. The first is your mechanical advantage. Your mechanical advantage. It is actually that phenomena which we calculate to determine whether the machine is actually useful in the purpose for which it is working. When we calculate it and we are seeing a low value mechanical advantage, then it means that the advantage of the machine is defeated. The purpose of the machine, of using such machine, is defeated. And what is the formula? Load divided by effort. Load divided by effort. That settles the score under this part. Load divided by effort. You put in effort, it overcomes a given load. So please, let me clear this. Whenever they are telling you a force of 50 Newton is used to overcome a load of mass 70 kg, or let's pick something simple. Let's say 7 kg. It's very funny at times how we have our students interpret a question like this. A force of 50 Newton is used to overcome a load of mass 7 kg. And they will ask you to calculate the mechanical advantage, and we'll see some students mixing things up, doing 50/7 or writing some strange values. It shouldn't be, because in this case, this is the load. And given the mass, you understand that mass is not the same thing as weight. Mass is just a function of what? Weight. As such, you are expected to go ahead, giving you the mass here. We are supposed to say that the weight of this load is going to be mg. And multiplying by 10, the true value of the weight you are considering is actually 70 Newton. Then you can proceed to say 70 Newton divided by 50. This is the force applied to overcome this load. This is the problem. The problem on top divided by the effort you are putting in. That gives you your mechanical advantage. That being sorted out, having the formula for mechanical advantage, then we go ahead to talk about the velocity ratio. But here is it. There's no specific formula I'll be writing for velocity ratio here, and it's for a reason. We'll be treating extensively the velocity ratio under the third aspect. So, efficiency here. Efficiency of a machine. What do you need to put in mind for efficiency of a machine? Yes, you'll be correct to say the mechanical advantage divided by the velocity ratio multiplied by 100. No wahala. This part is very correct, but also know that there are other formulas. What are the other formulas? Here we have it. Efficiency is also equal to work output over work input times 100%. This will have been all. The third one which you see them play with is always this guy. Check it out. We say, let's have it up, or efficiency is equal to, watch this, work done by the load. Work done on the load over work done by the effort times 100. You know why I'm giving you this one? UTME examination is centered around this, talking about efficiency most of the time. They ask it based on this guy and this guy. Few occasions you play with what? Work output over work input. It is always this guy. You know why? When you're having work done on the load over work done by effort, then you see them ask you a question by telling you, calculate the work done against friction. You will see your JAMB asking you a question like, calculate the work done against friction by a machine, and they will give you some parameters. And you start asking yourself, excuse me, work done against friction, where is that one again? Because they know that what? Students have already what? Acclimatized themselves with saving the formula mechanical advantage over velocity ratio. Students know it. Work output over work input. Students know it. But this third part, they don't digest it in full. Understand that work output means the work that was done on the load. Work input means the work done by the effort. But there's a problem. The work done against friction. That third guy, which we don't pay attention to. What is work done against friction? Check it out. Work done against friction. Work done against friction is simply equal to work done by the effort minus work done by the load. As simple as that. Remember we said efficiency of a machine can never be equal to 100%. Once you're having efficiency of a machine to be equal to 100%, it means you are talking about an ideal machine. Then you are making a reference to an ideal machine, meaning a machine that exists only in theory. In practical, you expect that what? The work done by the effort is always greater than the work done by the load. So it's expedient of you to know that what? The difference between the work done by the effort minus that done by the load is what we call work done against friction. Now that we have cleared the air on all these aspects, the third and final part, which you want to know, velocity ratio of various machines. Out of the plenty machines we have, only 5 are being emphasized, talking about Nigerian syllabus. Nigerian curriculum you will see 5 of these machines mentioned. Only 5 of them. Check them out. You might be familiar with some of them. Okay, because of space. Let's have it here. Velocity ratio. You want to mute yourself? You want to mute yourself. Somebody's mic is on. Velocity ratio of machines. So, I emphasize that efficiency, we check out MA over VR times 100%. We also put in mind work done on the load divided by work done by effort. Reason being that what? We have something we have called the work done against friction. Put that in mind. JAMB will sometimes talk about work done against friction. So know exactly what it is. It's just simply the difference between the work done by effort and work done by the load. Or we simply say work input minus work output. That is what we are talking about. So various machines. The first machine you want to know the velocity ratio would be your pulley or block and tackle system. Your pulley or block and tackle system, you need to know what the velocity ratio of this machine is. Whenever they give you a pulley, maybe you have a machine and they are drawing something like this. Pardon my diagram, just help me manage it. Now, assuming we have a machine that has these pulleys attached to it, your job is to figure out what the velocity ratio of this machine would be. And how do we easily pick it? The velocity ratio of a pulley system is only subject to the number of pulleys. That's all. Check out how many pulleys you have in the question. That is your velocity ratio. So based on this diagram here now, we can rightly say that what? The number of pulleys available would be what? 3. Number of pulleys. Equal to what? 3. As such, velocity ratio equal to 3. That's all. A pulley system has 5 pulleys. That is your velocity ratio. Don't stress yourself. So, understanding what the velocity ratio of a pulley system is as simple as ABC. So, we say that what? Velocity ratio of a pulley system is simply equal to what? The number of pulleys. So that settles our matter with regards to what? The pulley or block and tackle system. The second type of machine we'll consider will be your inclined plane. Number 2, inclined plane. Inclined plane. How do we get the velocity ratio for an inclined plane? Okay, let's have it here. Inclined plane now. This is what inclined plane looks like. You have a slant line, then you have this. Now, check it out. Let's assume we have a truck and you are trying to offload maybe a bike that has been loaded inside the truck. It is expected of you that what? The truck position where the what? Where the motorcycles are will be at the higher level, raised up level. We have a sledge laid down. Then you have the machines, they drive them off. They drive them off. They drive them off. They drive them off. Now, you discover that what? Effort is being made to load, to remove what? The machines off the raised platform. Now, This part here, imagine that what? You have this as a hill. Maybe this is actually what? A hill. And you have a vehicle trying to climb up the hill. What happens? The vehicle makes an effort to go up the hill. This is where you apply effort. This direction. As such, we call this place the effort distance. Effort distance. Effort distance. D subscript E. Effort distance. So you are applying your effort on this slant line. This vertical side, we tag it as our load distance. I'm saying it out so that for those writing and maybe the network is lagging, so that you know exactly what I've mentioned here. D subscript L. DE on this side and DL on that side. Those are the two most important parts talking about your inclined plane. And why is this? It is simply because we coined out that the velocity ratio for an inclined plane is simply 1 over sine theta. The formula for calculating your velocity ratio is 1 over sine theta. But wake up. 1 over sine theta. We know in mathematics already that anytime we are talking about sine theta based on SOHCAHTOA, we say that sine theta is opposite over hypotenuse. Opposite over hypotenuse. Meaning the side facing the angle over the hypotenuse side. So this vertical side and this slant side are what we use as opposite over hypotenuse. Now, talking about 1 over sine theta. So let's write it here. Let's write it like this. Since sine theta is equal to opposite over hypotenuse, 1 over sine theta will be equal to 1 divided by opposite over hypotenuse. And we know based on mathematics, when you have 1 over a given value, there's a flip over. As such, you are going to have hypotenuse over opposite. So it simply means that what you are having here, you can easily say that velocity ratio is either equal to 1 over sine theta, or you are saying effort distance, DE over DL. Effort distance divided by load distance. Effort distance divided by load distance. Effort distance divided by load distance. Let me make this analogy. Certainly nobody prays that such should happen. Now, here is it. Imagine a person crying out, "Oh, Nigeria is very frustrating. This and that. I'm tired. I'm this, I'm this." Then he was like, "Oh, what should I do? Oh, this is upstairs. I'm going to jump down from the balcony." Now, here is it. He thought in his mind, it was downstairs on the ground floor. He said he wants to jump from the what? Topmost floor. What will first happen? He has to apply effort to move up. Effort to move up. The distance moved by the effort. Having covered that distance, when he's now at the balcony, he's now thinking, should I jump or should I not jump? Now listen, the moment he has gotten to that up point, once he's about to take the step of jumping, he's already a gunners. Why? His body has been converted to what? A load. It does not need any effort to move down again. It becomes